2.4 complex numbers. What you should learn. Use the imaginary unit I to write complex numbers. We're going to add, subtract, and multiply them. We're going to use complex conjugates to get rid of the i's. And we're going to find solutions to quadratic equations. So this lesson is all about complex numbers. Now, hopefully remember how we did imaginary numbers in the last couple math classes you were in. Imaginary numbers are just I is just a square root of a negative number. So if I give you like square root of -9, you'd go, oh, that's the same thing as I square root of 9, which is the same thing as 3i. So this lesson is not about i's. We talked about them, imaginary numbers, in the lessons in the classes before pre-calculus. Now we're going to focus on complex numbers as a whole. So before today, you had real numbers, and that's all we knew. We're like have real numbers and imaginary numbers, right? So anything with an I here was an imaginary number, and then real numbers, anything without an I. So like we have rational stuff like 2/3, and we had irrational stuff like rad2, right? They all came down in this thing, and then we had real and imaginary, right? Two separate things that did not coalesce, but now we do. All numbers are called complex numbers. So they're usually written like this, 𝑎+𝑏𝑖. So that's a complex number. It's a combination of a real and imaginary number. So like you see here, -2 plus 3i, that's a complex number written in the form 𝑎+𝑏𝑖. Now keep in mind, all numbers are complex. So if I just give you number 3, that's the same thing as 3 plus 0i, so it's still complex. We would call it real because you only see the 3, but it's still a complex number. Likewise, if I just give you 2i, you can also just say 0 plus 2i. So this is imaginary, but it's also complex. So every number is complex. Some of them are imaginary, some are real. And then some of them are a combination, which is just complex. So that's what we're going to focus on today, is complex numbers. So that's the definition of complex numbers, right? So this is it. This is written in standard form. So a standard form of a complex number is 𝑎+𝑏𝑖. Right, and every number is complex. The equality of complex numbers, if I give you, that's all this is saying is I'll give you a plus 3i equals 5 plus bi. If these are equal, that means that the real part has to equal the real part, and the imaginary part has to equal the imaginary part. So that's the equality of complex numbers. So that's all that means, right? If you have two complex numbers equal to each other, that means their parts are equal. So the real parts are equal and the imaginary parts are equal. That's all that's about. So how do you add and subtract complex numbers? Honestly, pretty straightforward. You just add the real parts and you add the imaginary parts, and then you're done. And that's also how you subtract them. So let's do an example real quick, right? If I want to add these two complex numbers, all I'm going to do is add the real parts together. 3 plus 2 is 5, and then add the imaginary parts together. -i plus 3i is 2i. And boom, added. If we're going to subtract, don't forget to distribute the negative, and then add up like terms. So add up the reals, -3, and add up the complex, 0. So I get this, and then I can also just write that as -3. Again, standard form that they ask for that is real number in front, complex number in back. How do you multiply complex numbers? Kind of the same thing. There's one thing you have to keep in mind though. Note, remember that I squared is -1, and we always go that way. If you have an I squared, you can't keep it. You gotta write it as -1. Now we don't ever do this. A lot of people like get confused and they see I and they change it to square root of -1. You don't ever do that. If you have square root of -1, you change that to an I. You don't ever go the opposite way. So kind of the same thing here. If you have I squared, you change it to -1. So if I was going to do this one, well, this one we just distribute. I get -10 plus 15i. Right? Easy enough. Here's where the I squared thing is going to come in. So we're going to distribute. Remember, you could do area model if you prefer. I'm just going to distribute 2 times this, 2 times that. I get 8 plus 6i. Then we're going to distribute this guy to both of them. -4i minus 3i squared. And then, right there, right? You cannot leave an I squared alone. I squared is -1. So this becomes a -1. Now, keep in mind, it's a multiplication. You're not adding -3 and -1. You're multiplying them. So this is saying -3 times -1. So this is 8. Let's add these two. You get a plus 2i. And let's multiply these two. -3 times -1 is a +3. Then you add up like terms, and I get, we'll put in standard form, 11 plus 2i. So that's how you multiply complex numbers. I'm going to do this one real quick. I want to do this one because a lot of people mess this up. A lot of people just think you just square both of these. That's not the rule. If there's a plus sign or a minus sign, if it's a binomial, you have to rewrite it. When you square something, you multiply it by itself. So it should look like this. And then we distribute it one more time. So 3 times 3 is 9. 3 times 2 is 6i. 2i times that is 6i. 2i times 2i is 4i squared. I have an I squared again. So we got to change that to a -1. Keep in mind these are being multiplied, not added. So I'm going to get, I can add these two though. I'm going to get 9 plus 12i minus 4, right? It's 4 times -1, not 4 minus -1. So -4, add up like terms, you get 5 plus 12i. And keep it in standard form. So there we go. That's how you multiply them. Complex conjugates. So a conjugate, if you remember from in prior class, is where you do the opposite. So like where you change the middle sign. So if I give you this, the conjugate is you change the middle sign. And the reason we do that, the reason we have conjugates, is because when you multiply them together, you get a difference of two squares. You get this, right? You get a plus b times a minus b, you get a squared plus b squared. So this gets rid of the I, which sometimes you want to do. So if you ever want to get rid of an I, you multiply by its conjugate, and you'll eliminate the I. So let's do that here. Multiply each complex number by its complex conjugate. So if we're going to do a here, right, I have 1 plus I. Its complex conjugate, you just change the middle sign, 1 minus I. And we're going to multiply these together. 1 times 1 is 1. 1 times I is -I. I times 1 is I. And then I times -1 is -I squared. Once positive I, negative I cancel out, I squared is -1. But don't forget, it's negative times a negative, so a positive 1. And I just get 2. Notice I went away. Right, real quick, do the same thing here. Multiply 3 minus 5i by its conjugate. All we do is change the middle sign. That's all the conjugate is. Right, leave everything else alone. And multiply them. So just real quickly. 9 plus 15i. -5 times 3 is -15i. Minus 25i squared. And then I squared is -1. Middle cancel out again. 25 times -1 is a positive 25. And there's a 9, so I get 34. Again, notice the I went away. So conjugate's a nice way to get rid of the I. You can do the same thing with a fraction. Remember, general rule with a fraction is you do not want the denominator to be an I. So it's like proper math notations. You don't want no I's in the denominator. So that's a general rule. So I'm going to get the I in the denominator. So what we're going to do is multiply by the conjugate again, but we're going to multiply conjugate with the denominator. That's all I care about. So multiply by 4 plus 2i and 4 plus 2i. On the top, we just multiply, right? Distribute. We're going to get 8 plus 4i by multiplying 2 by both of them. And then 3i times both of them. So we're going to get 12i plus 6i squared. We'll deal with that in a second. On the bottom, we get a difference of 2 squares. Now, if you're pro, we're just going to do this. I'm going to take a shortcut now. Right? I know if I multiply this, we should get a squared minus b squared. So I'm not going to do the long thing anymore. I'm just going to do a shortcut. Oh, there's a conjugate. It's going to be 4 squared minus 4i squared. Let me write it like this. Minus 4i squared. Right? Complex conjugates. A squared minus b squared. So we're going to square this and square this. Let's do the top first. This gets me 16i. That gets me -6. Right? I squared is -1, so -6. Add like terms. And we get 2 plus 16i on top, right? 8 minus 6 is 2. On the bottom, this is 16. I squared is -1, so this is going to be, again, 4 times -1. You're multiplying, so positive 4. So I get a 20 on the bottom. and then this would be done if you're in like regular pre-calc. Honors, you can factor this. The top has, you can factor out 2, and that would reduce. So if I was in honors, I would factor out 2 from the top, 1 plus 8i over 20, and then now these two reduce. So I get 1 plus 8i over 10. That's the most factored form. Right, and so keep in mind, you cannot do like 2 and 20 do not cancel out. Anytime you have a fraction, they're like implied parentheses. So they can only cancel out, they're exactly the same. So the way to cancel these out is you factor out a 2. And now the implied parentheses are right here. And so the 2 and the 20 will be canceled out, reduced. So that's how you do that one. How do we solve a complex problem? Well, kind of like normal. So remember how you just rewrite it? If you have a square root of a negative, if you have a square root of a negative number, you can always just pull the I out, and then leave the square root there. So it's something like this. Like that's a proper, like that's just showing it, right? So we're gonna do that real quick. So if I'm gonna write a complex number in standard form. So first, I'd write like this. This is I square root of 3 times I square root of 12. Multiply them together. I times I is I squared. 3 times 12 is 36. Square root of 36 is just 6, so I get 6 times negative 1, because I squared is negative 1, so I just get negative 6. Something to that effect. Right, so I'm just like taking the i's out and then multiplying the radicals by the radicals and then reducing it. Here, remember, don't forget the square means multiply by itself, so you get something like this. But first, let's take away this I. This is I squared root of 3. We have to multiply by itself. So negative 1 times both of those, I get positive 1 minus I square root of 3. And then I get negative I square root of 3 times I squared square root of 9. Right? So I times I is I squared. Square root of 3 is rad 3 times rad 3 is radical 9. This is sending as a 3. And then that's sending as a negative 1. If you multiply those, you get negative 3. I can add these up and I get negative 2i square root of 3. There's 2 of them. And there's the 1 in front. Add up like terms. Negative 2 minus 2i square root of 3 is my final answer. You can factor out a 2, but there's no real point to that one. Okay, last thing we're doing. I believe. Yes, last thing we're doing. Sorry for that check. How do you solve these? How do you solve it with complex roots? Well, honestly, kind of the normal way. So let's solve this one. X squared plus 4 equals 0. Now this solve it. Get the x squared by itself. Subtract 4 from both sides. Square root it. Now before today, you'd be like, oh, I can't take the square root of a negative number. But now we can. It's an I. That's just 2i. That's just, well, technically it's just I square root of 4. But that's plus and minus 2i. Don't forget when you take the square root, you should get a plus and minus always, even with i's. Right, so you get the square root of negative 4. You can pull the negative out, make it an I, and then the square root of 4 is 2. So plus and minus 2i. How about something like this? Now, this is not factorable. So what to do is a quadratic formula, or you can complete the square, but let's do the quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. If you remember the quadratic formula, the coefficient of x squared is a, coefficient of x is b, and that's c. So we're going to get x equals negative 2 plus or minus square root of negative 2 squared minus 4 times a times c all over 2a. Okay, let me just simplify this. So that is going to be 4 over here. That's what, 15 times 4 is 60 minus 60. I get 2 plus or minus square root of negative 56 over 6. Notice how it has a negative right there, so that's just an I. So 2 plus or minus I 56 over 6. And that's our complex solution. Now, if we want to be pro about this, we should break that down. 56 is what? 2 times 28, which is 2 times 14, which is 2 times 7. I only need a pair. So that's the same thing as saying 2 plus or minus those amounts. So 2 square root of 14. 2i square root of 14 over 6. And also I could reduce this. They both have a 2, so I can factor that out. So 1 plus or minus I square root of 14 over 6, which reduces to 1 plus or minus I square root of 14 over 3. So you should always be kind of going to get the most simplified version. That's like I would expect my honor students to go all the way down here. But this is also the correct answer. But that's the idea.